Hello everyone, we are continuing on 3.9 graphing or solving polynomials by graphing. So we are on page 37 of the notes. We are looking at number 4. If you don't have your calculator yet, make sure you grab your calculator. We'll be going through those steps. If any time you get confused on the calculator steps or have a question or not, pause the video, go back, see if you can identify the steps. I will try and go slow and show all the steps with my hand. So read the problem. Doctors can measure cardiac output in patients at high risk for a heart attack by monitoring the concentration of dye injected into a vein near the heart. A normal heart's dye concentration is approximated by this equation, where x is the time in seconds after the dye is injected. Round any answer to the nearest hundredths. Alright, so I'm going to start by going to get my calculator out. We should be able to see both here. So I'm going to go to y equals, so I can put the equation in. Now we have to be a little careful with our negatives and our subtraction signs. So if I were to read this equation out, I would say negative 0.006x to the fourth. So I'm going to use the negative button, 0.006x to the fourth. And then I wouldn't say x to the fourth negative 0.4. I would say minus. Right? So I'm going to actually use the subtraction sign because I am actually subtracting this away. So minus 0.410 x to the third power. To get rid of, if it's up in the exponent, make sure you table over or else you'll keep writing this equation in the exponent. And then again, I'd say minus 0.053 x to the second, table over, plus 1.79 x. All right, and then I always do zoom 6. This is my standard window, a 10 by 10 window. And when I see this, you say, probably it looks like a pretty good graph, right? But let's think about this. I know I have a degree 4, so that's an even degree. And it's negative. The leading coefficient is negative. So when I have an even degree, both ends should go in the same direction, and negative, it should go down and down. All right, so I see my right end's down, but my left end's up. So I know I have to go farther in the negative x direction to make sure I get this whole graph. So what I'm actually going to do is I'm going to zoom out a little bit. So I'm going to use that zoom button. Zoom out. And if I press enter again, it'll just zoom the graph out. Okay. So here I could see, okay, it's all the way over. So I can see both my ends are now going down, so I know I'm in a good shape there. And so if this was just a general problem, I'd really want to make sure I see that whole graph. So I might even increase my y max by going to the window, and I'd increase my y max to maybe 100. And I press graph again. Let's see if I can see that whole graph. Yeah, I still can't, so I want to go even more. And there, okay, I could see the whole graph. So if this was just a general problem, I want to make sure I see the whole graph. I know exactly what's going on, what's happening, where's the maximum and mins. But let's think about this for a second. This is this equation, and x is the time in seconds after the dye is injected. All right, so if x is the time after the dye is injected, then we don't really care about negative time, right? Negative time doesn't really play a part in this equation because we don't really care about how much dye concentrate there is before the dye is in there. It doesn't really make sense. So I'm actually going to adjust my window accordingly. So I'm going to have my y min be 0 because that's the time is 0. I don't really need time before then. So my time's going to be 0. And then my y max, we were actually good at say, negative 10. Oh, sorry, positive 10. My y min, we'll start with negative 20 and 20, and we'll see if that's a good fit. And I graph it. Okay. So again, to get that, I went to my window to make a custom window. it doesn't seem like I need to go that high to negative 20, negative 20. So I'm actually going to adjust this again a little bit more. I'm going to adjust this to 0 and 10. I'll go negative 10 and 10. So I see a little bit of that graph, which I think is enough to show us. So again, my x max was 10 here. My y min was negative 10. My y max was 10. And to sketch a graph of this curve, something like that. So, and I like to graph, right? This is time in the x direction, and the y direction is die concentrate. Okay. So let's go and start solving some of these problems. It says, how many seconds does it take for the die concentrate to fall to a level of 0? So if we think about this problem, we're looking for a t and a specific t value when die equals 0. In this case, our die concentrate is our y value. So in this case, we're looking for when y is 0, what does t equal? Okay, so if I'm looking at my graph, well, when y is 0, t is here. We're really looking for this point. And that point, there's a couple names for it, right? That's our x-intercept. Or as we might know, those are also our roots or our zeros. So I want to find my x-intercept, roots, or 0. All right. The nice thing about the calculator, whenever we're trying to calculate things, it's all in this calc button. So to get there, I'm going to press second, calc, and I have these options: value, 0, min, max, intersect, and then some things you'll learn later on in calculus. So I'm looking for my x-intercept or my roots or my 0. They all mean the same thing. So my calculator option, it's always going to be 0. That's what the calculator chooses to use. So I'm going to click 0. And now I'm trying to isolate this 0 right here. So that 0 right there. So I am going to try and find my cursor. I saw that it was x equals 5, y is a negative number, so it wasn't on my graph. So I'm going to use my left and right arrows to kind of move the cursor until I see it. All right, and I see it's blinking here. And I'm trying to find, I want to be left bound to that point. So I need to table all the way left until I am left bound to that point. I'll press enter. I'll go to the right. And now I know I'm to the right because I'm below it now. I'm to the right of that point. Press enter. Then it says a guess. You can just try to put it close to it. I'm going to press guess again. And I get this point 3.19, comma 0. So 3.19 seconds after is when the die concentrate equals 0. So all right. So then, next question. Within the first 5 seconds, what is the maximum heart die concentrate? So I know here, right, is 3.19. And it just keeps going down after that. So I'm really looking for the max somewhere in here. So I'm really looking for like this point up here. So I'm going to do the same thing. I'm going to go second, that's trace button, or second calc to get to it. I want to find my maximum, so I table down to maximum. And again, it asks me to be left bound, but not left bound of the 0, left bound of the maximum. So I'm going to just table left, 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 until I know for sure, hey, I'm definitely left of that highest point. Press enter. Now I'm going to use the right arrow, go all the way till I'm definitely right of it. Press enter. And then I guess anywhere around where we think that maximum might be. Press enter. And I get this point. So I get the point 1.85, comma 2.17. All right. And it asks, what is the maximum heart die concentrate? So if I think about this, my x value is time, my y value is die. So the answer, the maximum die concentrate is going to be 2.17. And then lastly, it says, approximately after how many seconds will dye concentrate reach 1.23? So I know this dye concentrate, that's a y value. I want to find what is t when y equals 1.23. So it's similar to that b value, or the b question. We were trying to find our t value when y was equal to 0. When y was equal to 0, we have a special instance. It's our zeros, or our x-intercept. But here, I'm just trying to find an arbitrary y value. So what I'm going to do, actually, is I'm going to plug this equation into our y equals. So I have my original equation. I'm going to keep it there. But then I'm going to have y2 be that value I'm trying to find. So I table down. I say y is equal to 1.23. And I graph it again. And now I'm going to try and find those values of x that get me to have a y value of 1.23. So what I'm going to do, we're going to start with second calc. And hey, we're actually going to go down to intersect this time because I want to find the intersection of these two graphs. So I'm going to find this point and that point. Now, the commands are a little bit different. It's not left bound, right bound. It just says first curve and second curve. So first curve, you can see as I'm tabling left and right, I'm on this polynomial. I'll press, when I'm kind of close to that point, I'll press enter. If you look at the second one, I'm moving it right now. I'm on the line, so I want to get it kind of close to that intersection. Press enter. The guess is, again, just kind of anywhere. You can just press guess again. And I get this intersection point of 0.74, 1.23. So I know, hey, I did get my 1.23, so that is an x value that will give me that y value. I'm going to do it again. So I'm going to press second calc. This time I'm going down to find intersect. Hold up. Sorry about that, everyone. My phone was on low battery. So I'm going to continue on. I'm still on that first curve now. So I'm trying to find the second point of intersection. So I'm on the polynomial. I'm going to try and pinpoint this point over here. When I get close to it, I'll press enter. When I'm on the second curve now, I'm on the line. I'm going to go close to it and press enter. And then my guess, I'm going to press enter. And again, I have this point 2.77, 1.23. So there's actually two instances where this polynomial is equal to 1.23 dye concentrate. So there are these two values. So I would say t would equal 0.74 seconds and 2.77 seconds. All right. So try number 5 on your own. So pause the video, try number 5 on your own, and then I'll kind of go through it again step by step. All right, so you should have tried 5 on your own. I'll go through it one more time, how to go through these steps. So to start off, I'm going to go into my y equals. I'm going to type this equation in negative 0.125x to the 5th power plus 3.125x to the 4th. What did I do here? Something funky happened there. I'll start over. Negative 0.125x to the 5th. And then make sure you table over so you're not typing this all in the exponent. Plus 3.125x to the 4th. Table over plus 58. Now when I do zoom 6, right, so my zoom standard, I don't see anything. All right, so we got to try and find our function here a little bit more. So what I'm going to do is I'm going to start by just going to zoom. We're going to try something else. If you keep tabling down, right here's zoom standard, which is 6. I'm going to try and do zoom fit, or 0. I'm going to press enter. And this is a function the calculator has. It kind of estimates, it kind of tries to estimate where we think this graph might look like. So it gives us a little bit about this. Remember, we are having a degree 5 polynomial, so this is odd. So my ends are going to end different, either up and down or down and up, like that. So it's negative, so it's actually going to be, my left is up, my right is down. So I kind of see, all right, I'm probably good on the left-hand side, but my right-hand side, I'm not there yet. So I know I definitely need to go more in the X direction. So I'm going to go to my window now and try and custom make this. So I'm going to go window. I see my X, I need more in the X direction. I'm going to go all the way, I'm just going to guess. I'm going to start with 50 and see how we do there. My Y-min, yeah, the suggestion was 48, but we like to do a lot of things finding our zeros. So I know I want to at least go below the x-axis, sorry. So I'm going to do -10 for there, and then I'll keep the Y max for now. And I'm going to press graph. So at least now I have my left end going up, my right end going down. The only thing is I don't see the maximum value. So if I wanted to find the max at all, I would need to get a larger Y value. So I'm going to increase this. I'm actually going to just do a very large number. This is already at 43,000. I'm going to go all the way up to 100,000. Okay, and I'm going to press graph. And you can see there, I just barely see the tip of it, so I know I am good on that. And I'm going to start calculating this. So my window here, my x-min is -10, my x-max is 50, y-min is -10, y-max is 100,000. So when I go to draw a rough sketch, right, I know it looks like it goes to the bottom, but it does not actually start at 0, 0. One way I know that is I know that for any polynomial, this last value, that linear term, or that constant term, is going to be my y-intercept. So I know it at least starts a little bit above the y-axis, or the x-axis. Okay. And now my x is years, what my y is population. So they ask, in what year is the population of wildebeest expected to peak? So that's asking the peak, right? Think about it. I'm trying to find this peak, and I'm specifically looking for the year. So I'm going to be using my maximum here. So I'm going to go back into second calc. I want to find my maximum. Okay, and now I'm going to table left, right. I want to be left bound of that peak. So anywhere left bound is fine. Left, I'll table over to be right of it. Right peak. And then I'm going to go try and find a guess in between. Press enter. And it tells me, hey, my value, well, if you see that there, this point up here would be 20, 1,000,058. So it's actually a little bit higher. So I should actually increase my window a little bit so I actually see that full peak. But my calculator was able to find it for me. So it asks, what year is the population of wildebeest expected to peak? So that is looking for my x value. Now it's important to realize x is represented as a year since 1990. So it's 20 years after 1990. So it's actually going to be in year 210, right? Because if this starting point, it's not 0, it's actually 1990. This point is 20 years, sorry, this point is 20 years farther, so that's going to be 2010. All right. And then ask how many will there be? That's asking a population. So that's the y value. So I could actually kind of write this in a nice sentence. In year 2010, there will be 100,058 wildebeests. Okay. And then they ask, in what year is it expected that the wildebeest will be extinct? Think about extinct. I'm sorry if you couldn't see all that. Sorry. Extinct. That is when the population equals 0, or in this case, when y equals 0. And we just talked about when y equals 0, that's when there is an x-intercept, or a 0, or a root. The calculator calls it a 0. So I'm going to go into my calculator. I'm going to use second calc, table down to 0, press enter. I want to be left bound of it, so I want to be somewhere in this positive direction. I'll press enter, and I'll table right. I know I'm to the right of it now because my y value is negative, so that means I've already gone past that value, that x is 0. I've gone past it and to the right of it. I'll press enter. My guess, somewhere there, and I get this point 25.00 comma 0. So a little bit more than 25 years, but pretty much at 25 years. So I'm trying to find in what year will we see this extinction. It's since again I started at 1990, 25 years from there, so 25 years since 1990. So it would happen. They will be extinct in 2015. All right. And lastly, in what year did the wildebeest population reach approximately 78,706? Well, again, hey, that's a y value. So I can plug this in to my y value. I'm going to have a y. If this was y1, I'm going to just table down to y2. I'm going to plug 78706 in. Graph it. I see that equation across the top. I have 2 points. So again, I'm going to find 2 times that 2 intersections this occurs. So to do intersections, I do second calc, table down to intersect. So I'm on the polynomial function at first, so I want to get kind of close to that first intersection. Press enter, second curve, enter, guess, just enter. I have the point 16.49 and 78706. And second calc, intersect, try and find the second point. I'm on the polynomial, enter, on the curve, enter, the guess, enter. I'm at 22.58, comma 78706. So, in what year will the wildebeest population reach approximately that? Again, this is from 1990, so I have to add 16 to it. So, I am actually going to be, the years are going to be, you could actually kind of estimate this, right? If I'm 0.49 of a year, I'm like halfway through. So you could say approximately, I'm gonna run out of space, but I'll try and write it here. In year 16 plus 1990 would be 2000. And like I said, it's halfway, so I'm going to say approximately halfway through. (2006), and that's pretty close to halfway as well. Halfway through If you don't know, you could do 22 just plus 1990. Nice calculator step there to get 2012. And so approximately halfway through 2006 and halfway through 2012, the population of wildebeest will be 78,706. All right. To wrap this up all the way, this is just calculator hints at the very bottom to help us. To get to that calculate menu to see the zeros, the y-intercept, or the zeros, the min, the max intersect, it's second, trace. Right, this button here is trace, but you also, when you do second trace, it is the calc button. And then 0, you use this if you want an x value when y equals 0, right? Trying to find our x-intercept. The minimum, use this if you want to find a local min. Or the smallest value. And then similarly for maximum, you would use this to find a local maximum. And the largest value, or peak value. Maybe we saw peak in this instance. And then intersect, use this if you're given a y value and want to find an intersection. All right, that is all we have for today.